Welcome back to Elmer time.
I like Star Trek.
All right, let's talk about CB antennas. Starting off, no matter if you buy a very inexpensive CB radio with very few features or the most expensive large CB radio that you can find, they're both going to transmit 4 watts on AM and FM. They're both going to transmit 12 watts peak on sideband. And no matter how much money you put into a radio, they're not going to outperform the other, one or the other. It's the antenna that makes the radio. I mean, yes, you do get extra features with a more expensive radio, better filtering, etc., etc. However, for transmit and receive, for distance, the better the antenna, the better the radio is going to perform. And that doesn't just mean CB radios, that means basically all transmitting radios, transceivers, all transceivers. The better the antenna, the better the performance of that radio. It all comes down to this: how good your antenna is and how good your particular microphone sounds when transmitting your voice. You want to make sure that you have a clear, good sounding microphone on your radio and that it's adjusted properly. When you look at the antennas for CB radio, which is the 27 megahertz band, a quarter wave is a full quarter wave antenna would be a stainless steel whip at 102 inches, or 108 if you have the spring. But 102 inches is probably the best antenna that you can have for a mobile antenna. However, due to its length and size, it may be a little difficult to put on certain cars. That is why some people opt for smaller antennas or even magnet mount antennas. But you still have to take into consideration that once you purchase smaller antennas, you're also going into a give and take, because you're losing receive and transmit performance when you get a smaller antenna. That's just all there is to it. Even the most expensive magnet mounts are not going to fully compare to a full quarter wave 102 inch stainless steel whip. Even if it's mathematically the same with the coil on the bottom and the whip at the top, the extra length that's there makes a difference. Let's talk a little bit more about that. Okay, so you may find that you're only going to be able to use a magnet mount antenna on your mobile, which is a downsized antenna with a magnet on the base so that it will attach to a trunk lid or a roof of a car. Then you've got your permanent mount antennas where you could use a 102-inch stainless steel whip or a fiberglass whip of some kind. Problem is, when you use a very tall antenna, it becomes difficult to go into car garages or your personal garage at your house. Going through drive-thrus at restaurants, a very tall whip antenna will hit everything and anything. So keep that in mind. For home base antennas, such as your taller vertical antennas, you've got your Yagi or beam antennas. Vertical antennas for a base station, they're easier to put up. You don't need to add a rotor or a turning box for a vertical antenna because it transmits in an omnidirectional pattern already. It doesn't need to move once you've set it up on the house. Yagi, a beam, there is more money involved. The antenna itself costs more. It takes a bit more to tune the antenna prior to putting it all the way up on a tower. Plus you have to have a rotor and control box to turn the antenna, because a Yagi or beam is a directional antenna that points the signal to wherever you're pointing it at. However, you do get more gain with a Yagi antenna, which means more signal is output towards wherever it's pointing. A vertical doesn't really have that option. It might have a little bit of gain, but not much. However, it's a more simplistic antenna, and it can handle a higher wind load if you're in an area where you get a lot of very high winds, maybe even tornadoes. Some antennas might be able to handle very high wind load with the vertical antennas. Yagis or beams, they're more susceptible to getting destroyed in high winds and in heavy ice storms as well. I should also include with CB antennas the coax. If you're running a mobile setup in a vehicle, you have to make sure that the coax running from the antenna to your CB radio does not get damaged or pinched in any way, shape, or form. If the coax becomes pinched, you damage the coax, and as soon as you start transmitting, you can damage the radio as well, because more of the signal becomes reflected back to the radio in the transmit mode. Home base setups, you normally want to use a heavier, thicker grade of coax, such as RG8, just to withstand the elements for a longer period of time. Signal loss during transmit or receive is so finite at 27 megahertz. You don't really have to worry about coax quality that much. As long as all the coax that you're running is 50 ohms for mobile and home use. When installing a home antenna, make sure to use the heaviest mast or tower that you can come up with. Make sure it's installed correctly into the ground. Use plenty of guy wiring. Okay, here's some more information that I can come up with for mobile antennas, mobile CB antennas. If you're deciding to put a mobile CB antenna on your vehicle, there are some key things to think about before just running out and buying an antenna. And such as, number one, where do you want to put the antenna on the vehicle? Do you want to drill any holes into the body to install that antenna? Because some antennas require that kind of installation. Will you have any height clearance problems, such as garages, carports, trees, etc.? There we go with the 102-inch stainless steel whip. The best antenna, however, hits everything when you're driving around with that antenna. From where you want your antenna, how and where will you route the coax into the vehicle to your radio? There again, you don't want to pinch the coax, you don't want to heat up the coax because it'll melt. If it gets too close to an exhaust system or too close to the motor or transmission. Does your vehicle have a metal body or is it fiberglass? If it's a fiberglass body such as a Corvette, you can't use a magnet mount. You will have to find a way to mount an antenna somewhere on the body that is metal. Depending on the year of the vehicle, maybe on the bumper still may be metal. Does the chosen spot have the appropriate amount of metal for grounding the antenna? The antennas, when they are installed, they are separated on the hot side and the cold, on the ground side. The hot side, of course, would be the transmit and receive section. However, they also have to be grounded. So you have to make sure that there's a good ground on the antenna. Will the antenna be too close to an adjacent part of the body? This may lead to bad SWR, poor transmit and receive. I don't know how many times I've seen people with Jeeps install a hard-mounted, permanent mount, 3 or 4 foot fiberglass antenna right up against the back side of their body of their Jeep. Right, just maybe inches away from the body, all the way up. A CB antenna has to be out in the open for it to work properly. No holds barred. It has to be out in the open. There can't be anything metal next to the antenna. It has to be out in the open. If you have an antenna that's sitting right next to a, here's the back of the Jeep. Okay, and here's the tail light. Here's the spare tire. Here's the bumper. Okay, we got the idea. Well, they will install a permanent mount antenna right here and have it run up, right up against the back of the Jeep. Yeah, if they could get a somewhat good standing wave, which I highly doubt, their signal on receive and transmit is not going to be forward in front of the vehicle. All they're going to be able to hear is maybe a little bit in back of them and maybe a quarter of a mile to a mile behind them, and that's it. That's such a poor installation, it's laughable. And I've seen lots of bad installations on 18-wheelers as well. Have you chosen your antenna that will transmit and receive at your desired level of performance? Here's where the give and takes come into play. If you can't, for whatever reason, use a taller antenna because of clearance issues, you have to do a little research and look up to what you can use. Will the antenna and or mount be too close to an electrical noise source? Make sure that the antenna is not installed close to the motor. Best thing in the world to do is to keep it away from the motor. Many of the older vehicles may have noise emanating, RF noise emanating from, the spark plugs, spark plug wires, the rotor, the cap, the points, depending on how old the vehicle is. Bad grounding within the vehicle as well can produce RF noise. So it may take some moving the antenna around from point to point to get a really low noise floor on the radio while you're running the motor and driving. Will this antenna be placed on the vehicle for best performance? Here again, you want it out in the open. If it has to be, for whatever reason, has to be near the motor, put it at the very far end of a fender. Not up near the windshield, far end of the fender, so it's away from an A-pillar of the vehicle. Or on the back trunk lid off a bumper, as long as the car doesn't have an adjacent body line with the antenna. The roof is the best, but putting a 102-inch stainless steel whip on top of a roof of any vehicle, you're going to have problems. It's going to transmit and receive beautifully, but you're going to have problems. So let's move on. All right, let's talk about the SWR meter. This is probably the single most important external device that you could purchase for your radio setup, or at least use one prior to using your setup at least once to make sure that the antenna is tuned to the radio. Here is an example of a very old one. It's an old Micronta. There's not a lot to it really. It has an in and an out. Calibration for tuning. And once you've tuned it, then you check for your standing wave. And what the standing wave is, it's the reflected power that comes back from the antenna to your radio. And you want the reflected power to be as minimal as possible, because the less power that's reflected back to your radio, the more of it is being transmitted off the antenna and out into the air. A standing wave that's too high, too much of the reflected signal comes back to the radio and can actually burn out your transmit final transistors. So these little meters, they don't really cost a whole bunch. You can actually find them at Hamfest used for just a few bucks. I believe you can still buy used ones for 20, 30 bucks, maybe 40. There are more expensive ones that have more than one meter, so that you can have one for modulation and power and standing wave. This is just a cheap standing wave meter, but it can be used in the house, out in the field, in a car, in a vehicle, for testing to make sure that the antenna is properly tuned to that radio. A properly tuned antenna will outperform easily any antenna that's not tuned. So you want to make sure that your antenna is tuned. Let's talk about bad SWRs and how easy it is for it to happen. Just a quick checklist. Number one is if you buy the improper antenna. I witnessed one guy thinking he was buying a magnet mount CB antenna, and it turns out he bought a magnet mount VHF ham radio antenna for 144 megahertz. And he transmitted on it with his CB radio. People could hear him, but from not very far away, because it was an untuned radio. He was asking me why he was having problems with his setup. And what you do is you walk over this and a patch cord, plug this into the system, transmit, find out the SWR is completely off the scale. And you immediately look at the antenna and ask him what kind of antenna he purchased. So proper antenna, improperly adjusted in length or dimension. Some antennas have adjustments at the top, such as those fiberglass coiled type of antennas. They'll have a little screw adjustment at the top. If they are improperly adjusted, the standing wave can go off. Make sure that they have to be adjusted. Condensation or moisture inside the antenna. Some antennas that are made poorly, some fiberglass, will get water inside the antenna, or some that have coils, metal coils on the inside, if it's an older CB antenna. And if water gets in the coil, it changes the Q of that coil and throws the standing wave all off. Loose connections on transmit and or ground radials. You have to make sure that all antenna connections are tight. Not tight with a pair of vice grips or anything, but good hand tight. Unless it's a permanent mount outside. Permanent mount antennas outside do have to be very stout, because anytime an antenna hits something, if it's a little loose, the mount could release the antenna or mess up the threads on the antenna input. Corroded or rusty antenna connections. Yes, you have to make sure that all antenna connections are free of rust. If they are a bit rusty, take them apart, clean them with a 000 or quad 0 stainless steel pad. Blow them off really good, put it back together. Should be good. Dirty, corroded, or loose antenna to coax connection. If the coax connection is dirty, you do have on the back of the radio, if it's dirty, you do have the option of using a 000 or quad 0 stainless pad and cleaning these up a bit on the back of the radio. Do what you can. If it's too bad, you may have to have whatever connector replaced. Antenna touching or too close to an object. There again, the Jeep issue where the antenna is too close to the body of the body of the Jeep. Insufficient grounding of antenna mount. The antenna mount, if it's a permanent mount, has to be grounded to metal. And the metal has to be a large piece of metal in the vehicle, preferably the frame, or an aluminum piece that is attached to the frame of the car. Faulty antenna. Antennas do go bad after some time because of hitting trees and buildings. After so many times, they just go bad. Improper coax. If you're trying to run a CB setup that requires 50 to 52 ohms coax, and you found a great deal on some RG6 coax at 75 ohms, that's a no-no. You don't want to do that. You're going to find a standing wave issue. Proper coax, however, improper lengths. You will find that if you're running a 102-inch stainless steel whip, you want to run a certain amount of coax, an extra amount of coax length to get a good standing wave. You don't want to make it a very short piece. And also you don't want to coil the extra amount of coax in a circle in a coil. You want to do it in a figure 8. If you do it in a coil, you're going to have issues with the transmit and receive. Incorrect connectors. Yeah, if you have an incorrect connector, they just won't connect. You have to have the correct connectors. Connectors broken or loose on coax. Yes, that is an issue on coax ends breaking off if the antenna moves too much, or the antenna coax at the back of the radio. If the radio is moving too much, the coax bends more than normal. The coax and the connector will break apart there. You have to make sure that that doesn't happen. Coax improperly attached to connectors. Yeah, you'll have immediate bad standing wave if they're incorrectly connected to the coax. So make sure somebody does it correctly or have it professionally done. Bent or pinched coax, internal wire breakage. There again, do not pinch the coax cable. Whether it's rolling the window up into the coax or trying to shut a door on some coax, an automotive or truck door, you're going to pinch the coax and you're going to break it. Then the standing wave jumps, you're not going to be able to transmit, nobody will hear you talking on the radio. Coax insulation broken, cracked, or worn. Yeah, when coax gets too old, you do have to replace it. Moisture inside of coax, that does happen on occasion. You just have to replace the coax if moisture gets in there. You can try to dry it out, but you're just going to repeatedly have that same problem over and over again. And every time it gets to be raining outside, your standing wave jumps through the roof and then nobody can hear you talk. Dirty, corroded, or worn out connectors, same issue. Coax coiled in a loop. If it has to be coiled, use a large figure 8 pattern. We just spoke about that. Coax connectors loose on an antenna or radio. Make sure that the PL259s are completely all the way into the SO239s. All the way, not just loosely. They have to be tight. Good hand tight. Faulty coax. Yeah, that produces bad SWR. Sometimes you can buy brand new coax that has faults in it. Just how it goes sometimes. A malfunctioning radio. Sometimes you'll get a radio that acts like it's working properly, transmits, but it's only transmitting at half its power or a quarter of a watt or something to that degree. It may be that the transmit final is blown and you're only transmitting just a minute amount because the radio itself is bad, not the antenna and coax. Any inline coax accessories improperly functioning, such as an SWR meter, frequency counter, low-pass filter, etc. Anytime you introduce something into the coax line, you have more possible issues of something else going wrong with that transmit and receive. Too many inline accessories with improper length jumper coax. That's kind of a far and few between thing. I wouldn't worry too much about the lengths of the jumper coax. Most jumper coaxes are either 2 foot, 3 foot, or 5 foot. Most people use 2 and 3 foot jumpers and they're fine. Let's move on. Okay, let's talk about meters real quick on CB radios. There are 3 main kinds that are on CB radios up to current. You have your standard analog meter with a mechanically moving armature. Very small though, 1.5 by 3/4 of an inch. There are a couple models out now with a bit larger analog mechanical moving armature, but for the most part you'll see a lot of these radios with a very small meter. Next would be the LED meter. Sometimes they'll only have 4 segments, sometimes 5. Easy to read, day or night, very bright, easy to see in a car. LCD meters, more segments, has to be in a backlit situation to be able to see it. Okay to read while driving. The most difficult one to read while driving would be the very small mechanical meter. In this armature they call, in CB lingo, a needle. In CB lingo, each one of these segments they call a bar. The reason I'm talking about the meters is that in the event of a radio check, if someone asks for a radio check on the air, you really don't know what kind of radio that other person coming back to you has. If it's an analog, an LED, or an LCD, everything's going to be pretty much relative. You're not going to get anything perfect as far as an exact reading on their end, because there's so many variables. Let me talk to you about those variables. Okay, those variables, in the event of a radio check, and the person's asking, you know, how well are you receiving me over the air? The generalization of the meters themselves, including the variables, such as the radio's receive sensitivity and its indicating meter reading. Is it a 1 through 20? Is it just 4 or 5 digits? Is it 9 total bars? The radio to antenna matchup, standing wave ratio. If the antenna isn't matched properly, if it's a terrible setup, if the antenna is mounted on the back bumper right next to the body line of a Jeep, yeah, it's not going to receive very well. That's a big variable. The size or the amount of surface area of the antenna, the larger the antenna, the greater the amount of signal is received or picked up. Like what I was saying earlier, that mobile antenna, 102-inch stainless steel whip versus a 3-foot fiberglass antenna, there's going to be a big difference. The antenna's transmitting pattern, that also can go back to receive pattern as well. Going back to that Jeep, the Jeep's only going to receive better behind the vehicle because of the way it was improperly installed. There's many other variables in that category as well. Elevation and location. If that receiving operator that gives you the radio check is way up on a hill 1,500 feet above you, yeah, they're going to receive you very well. If they're down in a hole in between buildings in the middle of a suburban or city setting with lots of buildings around them, they're not going to hear you as well as if they were up on a hill. Obstacles blocking transmission along the way, trees, buildings, hills, mountains, etc. Well, there you go. Any large thing can disturb the radio path. Amount of RF power or wattage during transmit. If the person wanting the radio check is not transmitting their full amount of wattage due to bad standing wave, reflected signal coming back into the radio, or the radio itself isn't tuned properly from the factory, or if somebody's hands have been in it and messed it up, there you go. Other operators transmitting at the same time on the same channel may give a wrong signal reading. If two signals are coming in at the same time to that person trying to give you the radio check, there's going to be an overlap of signals. You can't really tell what the actual signal should be. The weather and sunspot activity. Yes, you will see a difference in receive depending on electrical storms. You'll see a difference depending on if there is a high solar activity where you're hearing somebody, if you're up here in the northwest United States and you're hearing somebody down in Mississippi stronger than you should be hearing somebody 10 miles away, well, there you go. A misaligned radio, if somebody's had their hands in it, turning, tweaking different variables inside the radio and messing it up, there you go. Adjacent channel interference, a strong signal on another channel may knock out or take away some of the radio's receive capability. If you're asking for a radio check on channel 16 and somebody's trying to come back to you, and there are some truck drivers on channel 17 right next to them, they're trying to hear you, they're going to be getting adjacent channel interference from that channel 17 as soon as somebody transmits and they're half a block away or less while transmitting. They're going to hear that adjacent channel interference. So let's move on. All right, let's talk about microphones real quick. When you receive a brand new radio in the box, when you first purchase one, you'll get a stock microphone, and the microphone element within that casing will generally either be a dynamic element or an electric element. The electric element requires a small amount of voltage from the radio up the mic cord to power the electric element. The dynamic element does not require voltage to become energized or to allow audio input. The rest of these in the line here will require a battery. These microphones here require, whether it's a mobile microphone, whether it's a base station microphone, they will require battery operation, whether it's a 9-volt, a couple of AA batteries, whatever. And they will also have variable controls depending on what they control and what they do. Starting off with the noise canceling microphone. These are very popular with truck drivers, CB radio operators on the road in a mobile situation that have a lot of noise coming in from their vehicle, hence being a noise canceling. They will amplify the audio, but they will also cut the high end, the static noise, the air rushing noise. It's more of a filtered audio, but it allows the voice to come through and take away the noise, hence noise canceling. Echo mics, reverb microphones, they also amplify the audio. However, they also add an echo or a reverb. These are mainly used by AM and FM mode CB radio operators. And most of the time you will hear them with the echo turned all the way up, which is very difficult to even understand what they're saying when they have that. The main thing with these echo mics, if you can turn the echo down to a reverb, a very minute reverb, it will actually enhance the audio, and the person on the other end listening to your transmission will hear your audio better. A clean, just a tiny bit of reverb, just tiny. But nobody does that. Compression microphones, they also amplify. the audio, but they amplify the mid frequencies, and then they clip the high and low frequencies. Just giving you the punch of that center frequency area of the voice audio. They do work. The Roger Beep microphones. These are basically just a regular amplified microphone, but they also have an extra circuit for a Roger Beep that can be turned on and off. The audio that's amplified also has a variable to turn up and down the amount of amplification that you want, which all these here also do, except for the stock mic. The stock mic does not have any kind of battery operation or variable control. Sometimes there'll be more than one beep circuit in the microphone depending on what you buy. And then there's just the standard power mic. It is an amplified microphone. It amplifies the whole audio spectrum that it can pick up. And these are very prone to what's called overmodulation, because people will tend to try to turn them up too high, thinking if I turn it up higher, they'll hear me better. And that's not the case. You need to have them turned up just to the right amount so that they are good, clean, and loud. It has to be clean audio. If it's turned up too high, the audio will splatter. It will just sound horrendous whenever you're trying to talk to somebody. It needs to be turned down to a point where it's clear, loud, and audible. These microphones can be found, again, either in mobile or base station use. I'm sure they're still widely available by different manufacturers. So let's move on to the next. Okay, during proper solar conditions, pirate radio operators, if you want to call them that, illegal CB radio operators, will have a modified CB radio or an export radio that's been modified, or a ham radio, amateur radio that's been modified, so that it can transmit in the what they call the free band or free bands above channel 40 or below channel 1 in this from the CB band. And what they do above channel 40 is that they will transmit on either upper or lower sideband. They will call out for long distance communications to see how far their signal can get out during these peak solar conditions, what they CBers call skip, and see how far they can get out. I have seen communications, or I've heard communications within the CB band on channel 38 lower sideband. A local communicated with an operator in Australia. They were coming in almost full signal. That's because of the solar conditions of that day. In the event that you would want to hear some of these illegal operators, it would be easy to do with a shortwave radio if it has a sideband feature or a beat frequency oscillator, BFO. You can tune in specifically, here's a station here, 27.555 upper sideband. That is a calling frequency for the pirate radio operators. Tune in there and listen. You will hear operators all around the world. It is illegal for United States operators to go up there and transmit, but it's not illegal to listen in on it. Operators that go below channel 1 on the 40 channel band usually will use the AM mode. And one particular frequency that's used a lot is 26.915. Being that it's an AM mode, you will hear AM mode lingo, so be aware of that. Operators will not go near or above 28 megahertz because that is the beginning of the 10 meter amateur radio band. And they know if they get too close to that, ham radio operators will come after them. They will find a way to shut your station down if you get near that. So, if you've got a shortwave radio, tune in, tune around. You may hear them out there. Okay, let's start with a few helpful tips with CB radio in the etc. pages. Used equipment. You can find lots of used equipment over the air. Many people will sell radios over CB radios over the air. CB radios, illegal equipment. Be aware that many times you will receive something where somebody's hands have been in that radio if it's used equipment. To what degree, that it's up in the air. Sometimes it could be just a slight modification. Sometimes they could have really destroyed the radio. Just know that if you're going to think about buying used equipment from somebody you don't know, you could be just throwing your money away. So let's move on to the next one here. An antenna on a car or truck is a flag to would-be thieves. Keep that in mind if you're going to put a radio setup in your vehicle. Also make sure that the radio isn't mounted where it can be easily seen from outside of the vehicle. Well, a radio should never be mounted on a dashboard anyway because the sun will damage the electronics. But just keep in mind that if you're in a heavily populated area, thieves know that an antenna means money sitting inside the vehicle. Power mics. Be aware that whatever the setting is for your CB radio and power mic, for it to sound good on AM and FM, may not sound good on sideband. Once you switch over to sideband on your radio, if it has that feature, you will want to lower your audio output. The power mics and single sideband radios don't quite mix the same as they do on AM and FM. So make sure to turn down your power mic a little bit so that people can understand what you're saying if you're using a power mic on sideband. Your voice range. People all the time on AM and possibly FM will be tuning their radios over the air without using a dummy load, and they will whistle into their microphone as they're tuning it, trying to get the most wattage and highest modulation that they can out of their radio. Well, that is not a proper way to tune a radio in the first place unless you're going to be whistling. If you're going to be talking over the radio, you need to talk on the radio while you're tuning it, if that's what you need to do. But of course you should be doing it through a dummy load and not over the air. But henceforth, don't whistle into a mic just to tune it. You're not tuning it for your audio, your voice. The radio should be tuned for your voice, not for whistling. Export radios. These have been around since, what, the 90s, I think? What they are basically is a 10, sometimes and 12 meter amateur radio, normally a mobile, that is designed actually to be modified. They will make sure that it's an easy modification. They won't tell you how to modify it, but you can find it online. The American market will buy an export radio, modify it so that they can talk in the CB band and around the CB band, above and below, as if you were to have a modified CB radio to shoot skip. The draw for people in the American public to buy export radios is the fact that it's so frequency agile, and they normally are much higher in your wattage output. So much though that, your CB radios, of course, is 4 watts AM and FM, 12 watts single sideband. Okay, well, an export radio on AM FM might do 20 watts, and sideband may do anywhere between 50 to 100 watts. So you can see the big draw there. The more wattage output, the stronger the signal output through your antenna. They are much more expensive than a CB radio. They are illegal to modify and use in the CB band. They are meant for an amateur radio operator that is licensed to use that radio in the bands specific for the radio, 10 and 12 meters, or 10 if it's just a 10-meter radio. However, because they're so easy to modify, you see them out there, you hear them out there on the air. Power supplies. If in the event that a person wanted to make a base station setup in their house or business, they could use a mobile radio inside the house or business, but they would need a power supply to take the place of the 12 or 13.8 volt DC battery out of the vehicle. If you use a power supply, you have to make sure that it is regulated, for one. 2, you want to make sure that it's 13.8 volts DC. 3, you want to make sure that the amp output of that power supply meets and goes above just a bit of what the CB radio requires during transmit. On some CB radios, if it's just an AM FM radio, you may only need 5 amps. However, if you're running a radio that's sideband and you're transmitting on sideband with 12 watts output, you may need 10 to 12 amps. So make sure that it's a regulated DC 13.8 volts and proper amp supplied. If the amperage supplying isn't enough from the power supply, the radio during transmit will be garbled, lights will dim in the radio, you will see a definite problem while transmitting, and that's due to the poor amperage supply. You have to have the proper amount of amperage out of that power supply. Okay, moving on. Okay, for those that are new into transceivers, CB radios or what have you, troubleshooting is a major part of radio, part of transceiver usage. So let's do some basic troubleshooting for those just getting into this. Starting off, let's say the radio won't turn on. See, there's no power. Well, what would cause this? Of course, you would check the power cord and all the connections. You would check the radio fuse or fuses. Some radios have more than one fuse. Check the vehicle's electrical system. Make sure that the vehicle is actually producing voltage to the radio. Check the battery of the vehicle. And check the radio's grounding. Make sure that the radio is properly grounded. Sometimes people forget to ground the radio properly. What if the radio is working, but you're getting poor reception? What would cause poor reception? Well, first of all, check the radio settings on the front of the radio. Check the squelch setting. Is the squelch turned all the way off so that you hear static? If you hear static, you're at the base level, you're at the maximum actually of what that setup that you have is going to be hearing. If the squelch is turned up too high, you're going to hear nothing because the squelch is closed. Turn down the squelch and then listen. Check the antenna and the coax. Make sure that the antenna and the coax are proper. Make sure there's no kinks or bends in the coax. Make sure the connections on the coax are proper and tight. Make sure the antenna is tight on the connectors. Make sure the antenna has proper standing wave, of course. Check the antenna mount. Make sure the mount is proper on whatever it's mounted to, that it's properly grounded. And check the operating mode of the radio. Again, check the radio itself. Make sure you're on the proper mode. If you're trying to listen to somebody on AM and you find that the mode is on FM, and you're wondering why everybody sounds garbled, well, that's because you're on FM mode. You need to be back on AM to hear the people on AM. What if you have a weak transmission? You're hearing everybody right, but nobody's hearing you. There again, immediately check the antenna and coax. Make sure that that is proper. Check coax for breaks or sharp bends. Once again, you'll see a lot of repeated things here. Check coax connectors. Again, coax connectors can lead to weak transmission if they are loose. Check operating mode of the radio. Same as poor reception almost there. Also check standing wave ratio at this point. If you have a bad standing wave, that could be the reason for your weak transmission. Check antenna grounding. Yes, the ground connector, the connection of the antenna mount. And check for corrosion on all connectors. Rusty, corroded connectors leads to bad connections. Bad connections lead to poor standing wave. Poor standing wave leads to poor transmissions or weak transmissions. What if you have good transmit, we'll call it TX, which is radio shorthand for transmit, but you have no or low modulation. Modulation meaning the audio. People aren't hearing you, but they see a good signal. What could that lead to? Why is that happening? Well, first off, you would check your microphone connections. Make sure that the microphone is fully plugged into the radio, and if it has a knurled twist connector on it. Make sure it's fully locked down. Check the mic gain on the radio. Make sure the microphone gain on the radio is turned to its appropriate point. It probably doesn't have to be all the way up, but find an appropriate spot where it should be. Talk closer to the microphone. If this is a new setup for you and you're not used to the setup, you're talking too far away from the microphone, bring the microphone closer up to you. Don't talk straight into it. Talk across if you're holding the microphone to the side, talk across to it, across the microphone screen. If you talk into it, you may find that it will sound garbled to everybody. If you talk across the screen, it'll sound better. If running a power mic, check volume on mic or replace the microphone's battery. Okay. Most power mics do have a variable setting on it for the amplification of the audio. Make sure it's on the right setting. If it is on the right setting, but nobody can hear you very well, it's time to check the battery or replace it. The battery in the microphone. Another thing that could present this is microphones have a way of having wire breakage inside the connector, where the connector meets the radio. Because of all the movement of the microphone wire, of stretching it out to pull it up to your face and putting it back down, picking it up, moving it around, the wires inside that connector will tend to fray and break. And at that point, you need to have the connector taken apart and resolder those wires back together and put the connector back together. That happens on just about any CB microphone that I've ever seen. And I've repaired hundreds of microphones for people that couldn't figure out what was wrong with the radio when it was just a bad wire on their microphone. So there we go, some standard basic troubleshooting for CB radio. Okay, some final thoughts here. Is the Citizens Band just a forgotten fad in 2025? I would have to say no, not yet. It, of course, is not as popular as it was in the 70s or 80s. Cobra Electronics, with them petitioning the FCC and getting them to add FM, and now adding FM to the extra modes now that we can use, or anyone can use, on CB in the United States. Is that going to be enough to bring up popularity? I personally don't think so. How did popularity get so much so in the 70s? Well, it was a lot to do with movies and music on the radio. It also had to do a lot with the times in the 1970s when we were going through a gas crisis. And CB radios were also being used for trying to find a gas station that had gas, or a gas station that had the lowest price in gas in that city. And it was used a lot for that. CB radios were used a lot for that. I think the only way for CB radio to become big, or at least bigger than it is now, and that would be again for it to be in some sort of blockbuster movie that everybody likes, to revise CB in United States culture again. Do amateur radios do amateur radio operators regret losing the 11 meter band? Well, we didn't have it for a long time. We did see that it was a good band for DXing. Not as good as the lower frequencies, such as 14 megahertz, 7 megahertz. Would we want it back? No, not now. Not because of the market that's still flooded with CB radios. Even though there aren't as many people on the air, CB radios are everywhere in the United States still. And the usage on AM and FM isn't quite proper radio etiquette for ham radio operators. I'm being nice when I talk about this. So ham radio operators are going to distance themselves from CB, the 27 megahertz, 11 meter band. It's a shame because it is a good DXing band. If the market wasn't flooded in the United States with CB radios, would ham radio operators want it back? Certainly. Absolutely. It is a good DXing band when solar conditions are proper. Amateur radio operators admitting their start in radio, and it began with CB radio. Well, it didn't exactly begin with me. However, when I was young, I did mess around with CB radio in the 80s, early 80s. Right about the time when the FCC license was dropped, 1982, 83, is when I started messing around with CB radio. However, radio didn't start for me. Ham radio didn't start for me because of CB radio. It helped me learn a lot about transmitters. But my beginnings with radio began with a shortwave radio and my great-grandfather and his shortwave radio when I was just a tiny kid. And I would listen to the shortwave radio with him, and it just amazed me that these transmissions could come in from around the world in a portable radio. Most ham radio operators that you hear on the air, most of the older seasoned operators, you won't hear them talk about CB radio. They just talk about it and discuss off the air. But there are some that did get their start in amateur radio through CB radio. That's just all there is to it. It's either going to be shortwave radio, or it's going to be CB radio, or possibly through them knowing an amateur radio operator and having them as an Elmer to help them right off the beginning get into amateur radio. Is CB radio good for emergency communications anymore? With the advent of cell phones, just about every single person having a cell phone in their hand nowadays, it seems unlikely that CB radio will ever be used for emergency communications on a daily basis. There are still instances where CB radio can come through in a pinch. When you're out in the middle of nowhere, you do not have cell phone signal, you have a CB radio in a truck or a car, and you can make contact with somebody, not necessarily on channel 9, but just somebody on any channel. And that's where it comes through. Radio communications still are a very good resource for two-way communications. It's just that CB radio two-way communications, for the most part, have become a madhouse. There's no real good radio etiquette on the AM and FM channels. There is a little bit of etiquette on the sideband frequencies, 36, 37, 38, 39, and channel 40. However, it's not perfect. So, there we go. See you next time. This is AD7LN. I'm out.